Okay, we got cut off there at the electron. So the electron is located in the shell, the cloud. It goes by several names, the rings. The charge, of course, is negative on the electron. And we call the mass virtually zero, which is actually about 1 over 1,840 AMU, but that is so small, we could pretty much count that as a zero mass.
Number 18, how do you find the mass of an atom, the mass number? So for mass number, what we just said was the protons and the neutrons both have a mass of 1 AMU. So your total protons plus your total neutrons gives you your mass number. So therefore, all of the mass is located inside the nucleus. Number 19, what two subatomic particles make up the nucleus? Well, we just said protons and neutrons make up the nucleus. Protons are positive and neutrons are neutral. So the overall charge of the nucleus is going to be positive. So if we have neon, which is atomic number 10, then I know I have 10 protons, so my overall charge of my nucleus is going to be plus 10. Number 20, label the location of metals with the number 1, metalloids with the number 2, and nonmetals with the number 3 on the periodic table. Give at least 3 characteristics for each category. So for metals, our metals are located on the left side of the periodic table. And if you're not sure, always look for gold, silver, tin, stuff like that you know. The metalloids are going to be right along this stair step right in here. There's only 7 of them. So all over this, up and down, up, down, all except for aluminum. Aluminum belongs on this side. It is a metal. And the nonmetals are going to be on this side. These are part of our noble gases and such over here. So, I'm sorry, those are number 2. Metalloids. So for metals, these are shiny, malleable, meaning that it can be stretched into long, thin sheets, and ductile. That's long, thin wires. For nonmetals, it's basically opposite that. For nonmetals, it is not shiny but dull. It is not malleable or ductile. They are brittle. And these are considered poor conductors or insulators, poor conductors of heat and electricity. And then there are our metalloids. For our metalloids, really main thing here, these are semiconductors, meaning they will conduct heat and electricity sometimes, just not all the time. Number 20, where would you find elements with similar properties located on the periodic table? So keyword right here is similar properties. Just like our family, we are similar to our family. Another word for family is groups. Groups go up and down. So these are our groups, and we will find similarities within the same group due to the same number of valence electrons. Due to their valence electrons, it's kind of like our DNA. We look and act like our family because we share the same DNA. Elements have similar properties and act like similar elements within their same group because they share the same number of valence electrons. And then number 21, what 2 pieces of information does the atomic number tell you? The atomic number is this number right here at the very top. This here is the atomic mass, which we really don't use, but this is my atomic number. So if my atomic number is 5, then I know that I have 5 protons, and I know that I also have 5 electrons, because those always equal each other.
Okay, number 22. What are valence electrons and what do they tell you about an atom? The valence electrons are the electrons on the outside outside or the outer shell on the last ring with electrons in the atom. And of course, they tell us the reactivity or the chemical properties of the atoms, of the elements. Number 23. What is the mass number of calcium if it has 20 neutrons? Okay, we talked earlier about the mass number comes from the protons plus the neutrons. We can look on the periodic table and know that calcium's atomic number is 20, which means it has 20 protons. They told us in the problem that it has 20 neutrons, so the mass number would be 40 AMU. Number 24, what element would have similar properties to sulfur? We talked earlier, to get similar properties, you need to go to the groups or families. And the groups go up and down. So if we look for sulfur on the periodic table, we will see that it is in group 16 or 6A. So all of the elements in that column have 6 valence electrons, which means they would all act the same. So we've got sulfur. On top of sulfur, you've got oxygen, then sulfur, then you've got selenium, tellurium, polonium, and livermorium. So those are going to be your elements that act like sulfur. Number 25, which subatomic particle gives you gives an element its identity on the periodic table? Identity comes from the protons. If we change the protons of an atom, we have a completely new element. We can change the other two, we can change neutrons, we can change electrons, still have the same atom, but protons identify the element. It is like your student ID number.
Number 26. Compare the following Bohr models and answer the questions. Okay, so first of all, by looking at this, it says, A, how many protons, neutrons, and electrons are in each element? So I'm going to go ahead and put that protons, electrons, and neutrons here. So from here, I can see that I've got 12 protons. I have 12 neutrons. We should know that protons and electrons are always the same. So if I've got 12 protons, I also have 12 electrons. The atomic number and the mass number. Well, my protons determine my identity, so my atomic number is 12. And my mass number, my mass number is going to be my protons plus my neutrons equals my mass. So 12 plus 12, my mass is going to be 24 AMU. C, how many valence electrons does each element have? Valence electrons are the ones on the outermost energy level. So in this case, I've got 2 valence electrons. And D, which element would be the most reactive? Well, I need to take a look at the other one first. So over here, I'm going to save that question for later. So here, for my protons, electrons, and neutrons, I've got protons are 7 from what it tells us here. My neutrons are also 7 from what it tells us here. My protons and electrons are always equal, so I have 7 electrons. Atomic number is also 7 because that tells us the identity of the atom. That's the proton. It's also 7. And the mass number, so protons plus neutrons equals mass. So 7 plus 7, my mass number is 14 AMU. How many valence electrons does this one have? So I've got 1, 2, 3, 4, 5. 5 valence electrons. So from here, my valence electrons tell me how reactive they are. So I've got one with 2 and one with 5. We can tell that this one over here, which is number 12, which is magnesium, is going to be more reactive than nitrogen over here, and that's because the quickest they can get to 8 is great. The quickest they can get to 8 by either giving away their valence electrons, so this needs to give away its 2, and this one needs to gain 3, because it has 5, it needs to gain 3 to get to 8. It's easier to give away 2 than gain 3, so this one is going to be the most reactive. So magnesium is most reactive because easier to give away 2 valence electrons than get 3 more.
Okay, number 27 is talking about the signs of a chemical reaction, and this says 5 signs. It's actually 6. We learned the mnemonic device. City girls love their cell phones on. The first C for city isn't one of the signs. It's just stands for chemical change, which always forms a new substance. Okay, we talked a little bit today about how the law of conservation of mass, so we have a certain number of atoms, we can rearrange them. When we rearrange them, we get a new substance. That's a chemical change. But of course, those atoms are going to remain the same number and the same type of atoms. Letter B is going to be the G for girls. G stands for gas. And gas can be bubbles. It can be smoke. It can be any sort of gas coming off, or even fizzing could be considered a gas. The letter C is love. L stands for light. And light can be flame, like glowing. It doesn't always have to be hot. It can be sparks. So any kind of light being formed. T there, T is for temperature change. And temperature change can be getting hotter, so warming up, or getting colder. And these are, again, remember all of these are unexpected changes. So putting it on the stove or sticking it in the oven, yes, we know it's going to get hotter. That's not what we're talking about. E is cells. C, the second C is for color change. Okay, and again, the key word to especially these two right here, guys, is unexpected. And the gas one as well, to be honest, because if we boil water, we're going to get bubbles, but that is expected. We're talking about unexpected changes here. P, phones, is precipitate. And this is when you get a solid formed from liquids. Like when milk goes bad. If you leave milk out for a few days, it's going to start forming that solid, clumpy, gross, nasty stuff at the bottom. That's a precipitate. And then O, on, is odor. Sometimes these odors are good and sometimes they are bad.
Physical or chemical reaction or change. So one solution settling to the bottom of the beaker and the other one rising to the top. So one at the bottom and one at the top, that's just density, which is going to be a physical property. Dissolving sugar. So you can evaporate the water and the sugar is going to be left over, so that's also going to be physical. You can normally tell just by these underlined words. Leaves changing color in the fall. Well, that is because they are decomposing, because they're dying. And so that is going to be a chemical change, a color change. Baking soda absorbs acid, absorbs, just like you would absorb water in a paper towel. It's still the same, still water and still a paper towel. So that is a physical change. A white solid forms at the bottom of a beaker after mixing 2 clear liquids. Well, it's forming something, and so that is going to be a precipitate, which is going to be a chemical reaction. Boiling water. That is, it does create steam and stuff, and bubbles. However, it is just a change of state from boiling water. It turns into water vapor, which is a gas, and we can capture that and turn it back into liquid water. So that's going to be a physical. Any change of state is physical. Melting is also going to be physical.